Okay, we're going to wrap up our point of interconnection discussion and lesson with a quick talk about power control systems. We're really going to try and answer the fundamental question of how do you add energy storage, or for that matter, more PV, to a service that's already maxed out with PV. Okay, that's where a power control system can come in. So let's take a look. We've got our primary power source, main overcurrent protection device. Information says we got a 200 amp bus bar, 200 amp main. So if we do 120% rule, 40 divided by 1.25, 32 amps Imax for our power source continuous output current rating. The most we can do on a load side connection following the 120% rule, and we're at our limit. That's all this can handle, this particular equipment. Well, that kind of is a bummer because the options to increase that size or increase what we can connect can be kind of expensive. We can't add any, for instance, energy storage, right? That might be something that we're interested in doing. People that have had PV systems on their house, now they want to get involved with energy storage. And, well, lo and behold, it's going to be more expensive than you thought because we're going to have to take into account the fact that you're already at your limit here, and that's going to have some extra costs associated with it. Well, this is where we bring in the concept of the power control system. Pretty simple what it really does. It controls the power from systems. It's a system that controls the power from systems. So we have a PV system connected to it. We have an energy storage system connected to it. And the power control system limits the current to whatever bus bar or conductor those outputs are connected to. Right, so they're both connected to the power control system. It modulates it so that we don't exceed the limits of what the bus bars or conductors downstream can handle. So a pretty simple concept. Now, there's a lot of other gear that goes along with it. This is obviously a very simple diagram. Current transformers to measure current levels, monitoring equipment, communications equipment. There may be overcurrent protection built into it. A lot of other parts and pieces that can go along with it. But a power control system is a listed product that is capable of doing this. So we could have more than we otherwise might think we'd be limited to in terms of PV and energy storage, but the power control system keeps it so that we don't overcurrent that bus bar. Now you might say, hey, well, I don't want to limit what I can do. This seems kind of dumb. Well, hey, the PV goes into the energy storage and we discharge it later, and we can discharge a combination of PV system and energy storage system that equals the maximum we can handle if that's advantageous or necessary. So there's a lot of flexibility here, and this is really going to help us deal with greater and greater levels of penetration of PV on the grid when we want to have the energy storage component as well. So 705.13 deals with power control systems, new in the 2020 National Electrical Code. And as I said, hey, it controls the output current of one or more power sources, such as PV EPCs, generators, other electronic power converters. It could control the output current of energy storage systems, batteries or fuel cells, or other equipment for that matter, electric vehicle power transfer systems, if it's car to grid kind of setup. So any of those power systems. Now, of course, it's going to depend on the particular PCS that we're using, who made it, what's it capable of integrating with, how many power sources can it control, what are the current ratings, limitations, and all of those sort of things. But you can see that the capabilities are going to be pretty robust, right? It limits the output current and protects the conductors and bus bars supplied by that power control system. If you think back earlier on, we mentioned this briefly in this lesson a couple of times where we're like, yeah, the rating we use is Imax times 1.25. Unless it's controlled by a power control system. Then we use the output of the power control system when we do our sizing calculations, right? Imax times 1.25 becomes somewhat irrelevant when the power control system is going to modulate that down if necessary to keep it to a set current limit. So that becomes the value we use when we do our bus bar calculations and feeder and other calculations. We start to use that power control system setting rather than the ratings of the systems that are connected to the power control system. Right. Now, we may have a device that's listed to function as an overcurrent protection device. It may have other functionality. It may work with some inverters. It may not work with others. It may work with some energy storage devices, perhaps not with others. Part of what's going on here is this is kind of new. and the listing capability to list things as power control systems is fairly new as of this recording. It is obviously going to be a big growth area for the industry going forward because this is going to allow us to integrate more and more varied systems together on the same service equipment without having to increase its size. All right, that was our point of interconnection lesson. Thanks a lot. I'm sure I'll catch you again soon.